Hey there guys, my name is Travis Field. I'm a rig welder with Legion Pipe and Fabricators in Nisku, Alberta. And guess where we are? We are in Canada right now with my friend JZ here, and we are going to be doing a 16-inch Schedule 40 stainless steel piping, and may as well get to it. Okay, so essentially what I'm going to be doing is going to be walking the cup because it's more aesthetic, it's a very high control, and it just looks better to weld overall. And so I'm going to be feeding in probably about 3 o'clock here. I'm going to be feeding down here, and I'm going to be using a really nice current that can control everything, all my movements. And I'm basically just going to be just walking the cup like this. I might use continuous feed technique, I might use dabbing, but essentially this is going to be my whole movement right here.
Basically what I'm doing, I'm just using a very fine side-to-side movement, and I'm just heating up the welding puddle. The very fine movement is heating up the welding puddle, and the welding puddle, the heat from the welding puddle is what is breaking down the tip of the filament metal there. And the welding machine I'm using is a Miller XMT 350. I'm probably about 90 to 100 amps right now. There's no land on this pipe. 16-inch Schedule 40. Probably going to be welding up maybe to about 4 o'clock, and then I'll pass the TIG torch off to JZ and he'll take over on his side.
So JZ's going to be taking over on his side now. My side started closing up quite a lot, so I figured, well, I'll just let him weld and then I'll just knife it through. So JZ's welding about 90 amps right now, and the machine we're using is a Miller XMT 350, which is a really nice, very precise, very controlled. It's like a laser beam. It's so focused. So the Purge Quality that we have is really good for flow. It's definitely over 100 parts per million. It's probably 100 to 200 parts per million. So you have some blue, some purple heat tint. What we could always do afterwards is we could just pickle the weld, take the heat tint out, and have a visual product.
So basically I'm just using a very nice continuous feed technique. And I'm just soaking the puddle in there, and basically all the energy is just being focused on the middle of the weld puddle, and the filament metal is being broken off. It's being melted into the weld puddle just by the energy of the torch there. Basically with heating up the weld puddle, if I heat up the leading edge and I'll end up opening keyholes, and I'll end up, when I bring the filament metal close, I'll prematurely melt the tip of the bevel off, or tip of the filament metal off. But if I heat up the weld puddle, the energy of the weld puddle itself will be bringing down the tip of the filament metal. So this will be a 308 filament metal and 304 pipe. I'm just starting off coming from the restart here and just taking my time here. Also, if you notice what I'm wearing on my arms there, it's actually like a cotton, they're actually hockey socks, but they're cotton and they handle heat very well. So if you're doing chrome or in the boiler, say, or doing mirror welds or whatever, then so my line of sight is looking at the leading edge, so I can see the leading edge on the external and internal. So the filament metal is actually just kind of pulling off. Looks like it's just funneling off. That's kind of how you gauge how much fill you give from the filament metal, and just the length of the funnel. I'm keeping relatively tight, and I'm just welding up to the teeth here. 16-inch skid 40. So we'll probably be doing the root pass, one hot pass, and then a couple of fill passes, a nice cat pass, probably a 1-pass cat pass.
Don't forget to check out weldlife.com for all your welding needs. weldlife.com. Don't forget to check out weldlife.com for all your welding needs.
Basically what we're doing here, this is just a hot pass. It's a little bit hotter than the root pass, just to get nice fusion and wash the weld puddle out. So essentially I'm making the fill relatively uniform, so if I have any misalignment or anything like that, the deposit metal is equal on both bevels. So if one comes down more than the other, the weld puddle I'll have to come down so there's equal fill on the bevels. And you don't have to put a lot of fill on the hot pass. Usually on the hot pass and even the first fill pass, it's pretty easy to wreck the root pass by putting too much fill. It's just essentially getting it too hot. If you get the root pass too hot, it'll get to the point where it liquefies and then it ends up rerunning portions of the root pass. It'll start melting. And it's very easy to wreck it. You get like sucked back and influenced by gravity and other things. Basically, as I weld, there's certain spots I do need to increase the welding current. The bottom usually will seam, it'll start out kind of cold. And when you start welding, usually about 4 o'clock, it starts being at a normal welding temperature. I'm going in the uphill position and I'm using my filler metal as somewhat of a heat sink. It is a solid mass and there's only so much energy it's going to take to use to keep the weld puddle in its liquid state. So in turn you can manipulate the rate of solidification and liquefaction of the welding puddle that way.
So what we'll be doing here is we just did the root pass and the hot pass, so now we're going to be doing the fill pass. So depending on how much fill that the pipe requires and depending on our fit up, it might need 1 or maybe even 2 fill passes. So we'll try and flush it out if we have enough material here. If not, 2 fill passes.
So I think the bottom here is a little bit wider. So we maybe we'll get away with 1 maybe. The weld puddle is very, very glossy and clear, very shiny. There's no oxides being pulled in on the piping itself. You can brush those oxides off. You'll see those oxides pretty badly. The nickel alloys would get pulled into the weld puddle, but the stainless is just a nice, clean glossy weld puddle. Just controlling the rate of solidification of the weld puddle here just by how much of the filler metal being a solid mass of energy that the weld puddle needs to break down. Originally at the bottom I started with the Tig torch away from me. It's just a little bit easier, it's a little bit longer to reach. It's easy just passing another wire here, so we'll go up further up the pipe. So if you look at, if you're able to see it, left bevel and right bevel, and I move to the right bevel, my left bevel, the puddle solidifies pretty quick there. And I take I'm able to stack my liquid weld puddle onto that previously deposited metal head, which has solidified. That's how I'm able to get deposition over a distance.
Okay, so we're going to start doing the cap pass here from the bottom to the top, and then I'll pass off to JZ here to do his side.
Could you turn the current down about 10? Or should maybe up 5. So we're using 308L filler metal. Right now we're using 1/8. The root pass we did with 232 just to have nice control on everything over the weld puddle. Even on large diameter piping, especially at the Purge. If the Purge is not very good, we'll still use 232. Basically with the cap pass here, I'm just washing from side to side here. We have nice lines that we've placed, and the reason why I do those lines is because the weld puddle will not go past those lines. It takes a lot of effort for it to, and you end up with a really nice straight cap pass. Very straight on the sides here.
Well, thank you for watching the video here, and if you like the welding helmets that we're using in the welding video, WeldLife.com, so 16-inch Edge 40, and thanks for coming to Canada here.